Okay, so in this video we're going to talk about expected value, and this is the formula here we're going to use. Ex is the expected value of x, which is the sum of, sigma here just means the sum of, or adding up the values of, x multiplied by the probability of getting x. So for example, if we have a spinner here, it's divided into quarters here, and we have a little arrow here. If you just flick that arrow, it spins around and lands on one of these numbers. So if you did that, you know, an infinite number of times, what would be the average value you would expect to get? And that's our expected value, really. So I'm going to work on this problem here, which involves two circular spinners, or sort of circular anyway. I'm not a very good drawer of circles, but anyway, we have two circles here, and we have these little red arrows, and you spin this arrow and you spin this one here. You add up the two values that the arrows land on. So for example, if it landed on 3 here and 6 here, the result would be 9. 6 plus 3 is 9. Okay, so it would be this value here. So we want to work out what would be the expected value when you spin these two spinners. So we're going to work that out using this formula here. The first thing we need to do really is write down all the probabilities. We've got to work out the probabilities of getting 5, 6, 7, 8 and 9. Okay, so what we're going to do is just work out, say, 5 first. What's the probability of getting a 5? So how can we get a 5? If we spin this spinner and spin this spinner here, what way can we get a 5? Well, the only way we can get a 5 is if this one here lands on the 4 and this one here lands on 1. There's no other way we can get a 5. So the probability of this arrow here landing on a 1 is a quarter, and this one here would have to land on a 4, which is also a quarter because it's a quarter of a circle. So our probability here is just simply 1 over 16. This is our probability of getting a 5. Okay, so what about a probability of getting a 6 then? Well, there are two ways that we can get a 6. If this arrow here lands on a 1 and this arrow here lands on a 5, that'll give us a 6. So the probabilities are this landing on a 1 is a quarter, and this landing on a 5 is a quarter also, so that's a quarter times a quarter. Or, so we're just going to add, another way of doing that is this spinner here, this arrow here landing on a 4 and this one landing on a 2. So that's also a quarter times a quarter. So we'll write down a quarter here times a quarter. So when you multiply these two, you get 1 over 16 plus 1 over 16. So that gives you 2 over 16. So the probability of getting a 6 when we spin these two spinners is 2 over 16, or 1 over 8. We leave them as 16ths for the moment. Okay, so what about the probability of getting a 7? Well, there are three ways we can get a 7. We can, let's see, we can go 6 here and 1 here. So that's a quarter. So we write down a quarter multiplied by, if we get a 6 here, it's a half. Probability of getting a 6 on that one is a half. Or, so we'll add, so this is a half times a quarter. So, or the next way we can do it is, let's say we go a 5 and a 2. So that's a quarter times a quarter again. Or, so we're going to add, we can go 4 and 3. So 4 is a quarter, and the 3 there is a half. So we have to do all of this, multiply that out, multiply this out, multiply this out, and add those three fractions. And when you do that, you get 5/16. 5 over 16 here. So the probability of getting a 7 when we spin these two spinners is 5 over 16. We do the same for 8 and 9. Well, 8, there are two ways, I think. Let's see. We can go, let's say, 6 and 2. So that 6 is, the probability of getting a 6 here is a half. So that's a half. And the 2 is a quarter, so we can go a quarter there. Or, so we want an 8, so we can go 5 and 3. So 5 is a quarter. Times the 3 there is a half. That's the only way of doing it, I think. Yeah, no other way of getting an 8. Yep, so if we do that, if we do these two fractions, multiply these two fractions, multiply these two fractions, add them, we get 4 over 16. 4 over 16. So the probability of us getting an 8 when we spin these two spinners and add them together is 4 over 16. And the last one is a 9. I think there's only probably one way of getting a 9. We can spin this spinner, get a 6, spin this spinner, we get a 3. So that's just simply a half times a half. So that'll give us a quarter here. Or we'll just say 4 over 16 just to make it calculations easier down here. So we have all our probabilities here now for spinning these two spinners and adding the two results. These are the probabilities of getting a 5, 6, 7, 8 or 9. These are the only numbers you can possibly get when you add these numbers together, 5, 6, 7, 8 or 9. So let's work out our expected value then. Okay, so our expected value EX is going to be our number multiplied by our probability, our number multiplied by our probability, number multiplied by probability here and here, number multiplied by probability here as well, and then we add them up. In other words, it's going to be the sum of our x values, which are 5, 6, 7, 8 or 9, multiplied by the probability of getting those x values. So really we have to multiply these here, multiply x by the probability of getting x, and then add up all our answers basically. So what does that mean? Let's see. The probability of getting a 5 is 1/16. So we've got to multiply 5 by 1/16 plus, this is our sigma here, we're adding all these up. 6, we could get a 6, so we multiply that by 2/16. We've got a 7 here, that's 5/16. We've got an 8 here, so we multiply that by 4/16. And then we have a 9 here, and that is also 4/16 here. So if we do all of this, multiply them out individually and then add our answers together, we should end up with 7.5. So our expected value, if we were to repeat this experiment over and over and over again, we would our expected value is 7.5. Now our expected value doesn't have to be one of our outcomes. These are our outcomes here. Our only possible outcomes are 5, 6, 7, 8 and 9. Our expected value is 7.5, which is not one of these outcomes, but it doesn't have to be. So for example, if this was in a fairground, for example, and you had to spin these two spinners and you add them up, and if you whatever values these land on and you add them together, that's the amount you won. So this is €1, €2, €3, €4, €5, €6. Your expected value, if you play that game over and over again, your expected value would be 7.5, €7.5. So if the person running this particular game charged you €8, they would make a profit and you would lose. If they charged you, for example, only €4, you would on average win €7.5, so it would be a good game for you to play. You would win on average. You may lose sometimes, but you will win more times than you lose, and you will win on average €7.5, €7.50. But you're only paying €4, so you're going to win eventually. Okay, that's it on expected value.